Overconfidence can lose wars. German high command sneered at American fuses early on, a mistake that would cost them dearly, long before the famous proximity fuse arrived. You see, when we think of game-changing technology in World War II, minds often jump straight to things like the atomic bomb, radar, or indeed the proximity fuse, that clever device that made Allied shells explode near their targets without needing a direct hit. And rightly so, those were marvels of science and engineering that had a tremendous impact. But history is layered, and sometimes the groundwork laid by simpler, less glamorous technology plays a role just as crucial, especially when your enemy fails to give it the respect it deserves. Today, we're pulling back the curtain on a different story, one set in the earlier days of the conflict, before the proximity fuse truly made its presence felt on the battlefields of Europe and the Pacific. We're looking at what happened when Nazi Germany looked down its nose at conventional American fuse technology, the everyday mechanisms that made bombs and shells go boom. It was an attitude rooted in a belief in their own supposed technological superiority, a dangerous assumption that American mass production meant sacrificing quality. What they failed to grasp, however, was the sheer power of American industry and the ingenuity focused not just on moonshots, but on making reliable, effective tools of war in staggering numbers. This underestimation wasn't just a matter of opinion. It had real consequences in the grit and grime of combat, influencing tactics, shaping battles, and setting the stage for even bigger surprises down the road. What exactly were these conventional fuses? How did the German high command misjudge them so badly? And most importantly, what price did they pay for this arrogance before the proximity fuse even entered the equation in force? Stick with us as we uncover this often overlooked piece of history. If you appreciate deep dives like this, hitting that like button really helps us bring more stories to light for everyone interested in understanding the past. To really understand the situation, we first need a clear picture of what we're talking about when we say conventional fuses in the context of the early 1940s. These weren't the highly sophisticated electronic devices that came later. We're primarily talking about two main types: contact fuses and time fuses. Contact fuses are the simplest concept. They detonate the shell or bomb upon impact. Think of a firing pin hitting a detonator when the projectile abruptly stops against a target. Simple, direct, and they've been around in various forms for a long time. Then you have time fuses. These were designed to detonate the projectile after a predetermined amount of time had passed since firing. This was crucial for things like anti-aircraft fire, where you wanted the shell to explode at a certain altitude near the plane, or for artillery barges meant to burst above enemy trenches, showering fragments downwards. Early time fuses were often powder train-based, literally a slow-burning fuse inside the shell housing, ignited upon firing. Later, mechanical clockwork mechanisms became more common, offering greater precision. You'd set the timer before firing, calculating how long it would take the shell to reach the desired point of detonation. Now, American fuse technology at the outset of the war, say 1939 to 1941, wasn't necessarily revolutionary compared to what the Germans or even the British had. There were certainly challenges. Early designs could sometimes be complex to manufacture consistently. Reliability could be an issue under the harsh conditions of combat: extreme temperatures, acceleration forces, rough handling. Powder train fuses, in particular, could have variable burn rates depending on atmospheric conditions or manufacturing inconsistencies. Mechanical time fuses, while more precise, required intricate clockwork that needed careful manufacturing and calibration. Contact fuses needed to be sensitive enough to detonate on impact but robust enough not to go off accidentally during handling or firing. So, perfection wasn't the word. But what America did have, even then, was a burgeoning industrial capacity geared towards mass production. The designs, while perhaps not always cutting edge, were often focused on being producible at scale. Reliability was certainly a goal, and American engineering put a lot of effort into making things work consistently, even if it meant sticking to slightly less complex designs than some European counterparts. Think rugged, functional, and built by the millions. This American approach, however, stood in contrast to certain aspects of the German mindset at the time. German engineering had a well-deserved reputation for precision and innovation, often pushing the boundaries of technology. Their scientists and engineers were brilliant, creating sophisticated weaponry that often seemed years ahead. Think of their early successes with rocketry, jet aircraft development, and advanced tank designs. There was a palpable sense of technological pride within the Third Reich, fueled by early military victories and propaganda that emphasized German superiority in all fields, including engineering. From this viewpoint, American mass production often looked crude. The stereotype was quantity has a quality all its own. But the unspoken implication from the German perspective was often that this quantity came at the expense of true quality and sophistication. They saw American tanks initially as inferior designs, American aircraft perhaps lacking the edge of their Messerschmitts and Focke-Wulfs. And this attitude, many historical accounts suggest, extended to the less glamorous components like artillery fuses. Why would a nation seemingly focused on just churning things out possibly match the precision and ingenuity of German fuse design, which sometimes involved complex and delicate mechanisms? They might have believed their own time fuses were more accurate, their contact fuses more reliable or sensitive. There was a tendency, perhaps, to overestimate the complexity required for effectiveness and underestimate the impact of sheer numbers and battlefield reliability. This created a dangerous blind spot. Because what if that American focus on simplicity, ruggedness, and massive scale wasn't a weakness, but a fundamentally different and potentially devastating kind of strength? What happens when an enemy consistently underestimates the tools you bring to the fight, even the basic ones? It's easy to focus on the later, more dramatic technological shifts, but even in the early stages of the war, this German underestimation coupled with the reality of American production started to have effects. Let's look at the Battle of the Atlantic. German U-boats initially wreaked havoc on Allied shipping. American depth charges, used to combat these submarines, relied on hydrostatic fuses, designed to detonate at a preset depth based on water pressure, or sometimes contact fuses. While early tactics and detection methods needed significant improvement, the sheer number of depth charges the U.S. Navy and Coast Guard could deploy, thanks to mass-produced, reliable enough fuses, began to matter. A U-boat commander might scoff at the theoretical precision of an individual American charge compared to a German equivalent, but facing relentless barrages from multiple escort vessels, day after day, changed the equation. The probability of damage increased simply through volume. Similarly, consider the early strategic bombing campaigns over Europe. While American daylight bombing tactics faced horrific losses initially due to fighter interception, the bombs themselves, equipped with standard impact or time delay fuses, did their job when they reached the target. German defenses were formidable, but the constant pressure from waves of bombers, each carrying tons of explosives triggered by these supposedly unremarkable American fuses, began the long, grinding process of wearing down German industrial capacity and morale. An individual bomb might be seen as crude, but thousands upon thousands raining down, detonating reliably on factories, rail yards, and cities, created a strategic problem that couldn't be ignored. Think about the artillery duels in North Africa, Sicily, and later in Italy and France. American artillery gained a fearsome reputation, not always because individual guns or shells were vastly superior in design, but because of the sheer volume and speed of fire they could deliver, the famous time on target barrages where shells from multiple batteries would land simultaneously. This required not only well-trained crews and good fire control but also millions of reliable shells with dependable fuses. A dud shell is useless no matter how accurate the gun. A fuse that fails to detonate at the right time or height drastically reduces the effectiveness of a barrage. The American ability to produce fuses, both contact and timed, that worked consistently, in astronomical quantities, allowed their artillery to maintain a relentless, destructive tempo that often overwhelmed German positions. German soldiers frequently commented on the intensity and ubiquity of American artillery fire. While they might have admired the technical sophistication of their own 88mm guns, facing the sheer crushing weight of American shelling, day in and day out, was a different reality. How did German forces react to this? Initially, successes enabled by standard American fuses might have been chalked up to luck, or perhaps attributed to other factors, superior numbers of guns, better Allied air support. There wasn't necessarily an immediate recognition that the fuses themselves, the small, mass-produced hearts of the projectiles, were a key enabling factor. The prevailing attitude of technological superiority likely persisted. But relying on luck wasn't the American way, and dismissing enemy capabilities is a dangerous game. behind the front lines, back in the factories across the United States. A different kind of war was being won, the war of production, standardization, and relentless incremental improvement. They weren't just making lots of fuses. They were learning, adapting, and refining, even before the proximity fuse project reached maturity. What were they really up to that the Germans failed to fully appreciate? The story of American fuses in World War II isn't just about clever design. It's fundamentally about the miracle of American manufacturing. Even before the war, the United States had pioneered techniques for mass production, standardization of parts, the moving assembly line, meticulous process control, famously associated with figures like Henry Ford. When the nation mobilized for war, this industrial philosophy was applied to everything, including the complex and often dangerous process of manufacturing munitions and their fuses. Think about what goes into a mechanical time fuse. Tiny gears, springs, escapements, all needing to be manufactured to precise tolerances and assembled correctly, often by workers who were new to the job, including millions of women entering the workforce, symbolized by Rosie the Riveter. American industry rose to this challenge. Companies that previously made clocks, watches, or other intricate mechanical devices pivoted to fuse production. Eastman Kodak, for example, known for cameras, became a major fuse manufacturer. Entirely new factories were built, assembly lines designed, and rigorous quality control procedures implemented. Standardization was key. Designing fuses not just for performance but for ease of mass production meant simplifying components where possible, using materials readily available, and ensuring parts made in different factories were interchangeable. Quality control became a science in itself. Statistical process control methods were employed to monitor production lines, identify potential problems early, and ensure a high degree of reliability. Fuses were subjected to rough handling tests, temperature cycling, and test firings to ensure they would function under battlefield conditions. Every step, from sourcing raw materials to final assembly and inspection, was optimized for both speed and consistency. Now, contrast this with the situation in Germany. While German engineering remained brilliant, their manufacturing faced significant constraints as the war progressed. Bombing campaigns increasingly disrupted production. Resources became scarcer. Their emphasis on sophisticated, sometimes overly complex designs, while impressive on paper, often made mass production more difficult and slower. Tolerances might need to be tighter, requiring more skilled labor which was increasingly in short supply. Quality control could suffer under the pressure of wartime demands and Allied bombing. This isn't to say German fuses were bad, many were excellent, but producing them in the sheer, overwhelming numbers America achieved, while maintaining consistent reliability across millions of units, became increasingly challenging for the Third Reich. While American factories were churning out fuse after fuse, companies like the Belittled watch company were applying their expertise to improve timing mechanisms, making time fuses more reliable. Chemical companies worked on improving the stability and consistency of powder trains for simpler fuses. Metallurgists developed better materials for fuse bodies and internal components. It was a nationwide effort, involving collaboration between military ordnance experts, university researchers, and private industry, all focused on making sure that when an American shell or bomb was sent on its way, it would detonate as intended. So, the Americans weren't just making more fuses, they were making reliably functioning fuses in quantities the Axis powers simply couldn't match. How did this combination, massive quantity, dependable quality, and persistent German underestimation, begin to fundamentally alter the equation on the ground, even without a single proximity fuse being fired? War, especially a global conflict like World War II, is often decided not just by brilliant maneuvers or technological breakthroughs, but by sheer attrition, the gradual wearing down of the enemy's ability and will to fight. And it was here, in the relentless, day-to-day grind of combat, that the American advantage in reliable, mass-produced conventional fuses truly began to tell, long before the proximity fuse became a major factor. Consider artillery again. The effectiveness of an artillery barrage depends heavily on the percentage of shells that actually detonate correctly. If even a small percentage of fuses fail, it significantly diminishes the impact. Conversely, high reliability means more explosions per salvo, more fragments hitting the target area, more suppression of enemy positions. The American industrial complex ensured that U.S. artillery batteries generally had a very high confidence level in their ammunition. This allowed them to execute complex fire missions like time on target with greater effect. It meant that when infantry called for fire support, they could count on shells bursting where and when they were supposed to. This constant, reliable rain of steel had a profound attritional effect on German forces. It disrupted troop movements, destroyed equipment, suppressed defensive positions, and inflicted casualties. German soldiers learned to dread the sound of incoming American artillery, not just because of the number of guns, but because those shells almost always worked. Think too about anti-aircraft fire in the pre-proximity era. Hitting a moving aircraft with shrapnel from a timed explosion miles away was incredibly difficult. Success often depended on putting up a massive volume of fire, creating a dense cloud of explosions in the predicted path of the aircraft. Again, fuse reliability was paramount. If a significant number of your anti-aircraft shells failed to burst at the correct altitude due to faulty time fuses, the density of that flak cloud decreased, and the chances of hitting the target plummeted. The consistent performance of American mechanical time fuses, produced in the millions, allowed anti-aircraft batteries protecting ships and ground troops to put up more effective barrages. While hit rates were still low compared to what the proximity fuse would later achieve, the sheer volume of reliable fire forced enemy aircraft to fly higher, take evasive action, or risk damage, degrading the effectiveness of their attacks. This reliability enabled sustained campaigns. Logistics is the backbone of any army. Knowing that your ammunition supply is dependable allows commanders to plan operations with greater certainty. The confidence that American shells and bombs would function as expected meant less waste, more efficient use of resources, and the ability to sustain intense combat operations for longer periods. Now, compare this to potential issues faced by the Germans. While specific data can be hard to pin down for every fuse type throughout the war, anecdotal evidence and post-war analysis suggest that the complexities of some German designs, combined with wartime production pressures, occasionally led to reliability issues. A sophisticated fuse that fails is worse than a simpler one that works. Any lack of confidence in ammunition could subtly influence tactical decisions, perhaps being slightly more conservative with artillery expenditure, or less aggressive in planning operations reliant on perfectly timed barrages. Even small differences in reliability, multiplied by millions of shells fired over years of war, could add up to a significant disadvantage. This relentless pressure, enabled by the unglamorous but dependable workhorse, the standard American fuse, manufactured on an unprecedented scale, was steadily grinding down the Wehrmacht. But incredibly, the Nazi leadership, still perhaps clinging to their belief in sophisticated wonder weapons and underestimating the brute force of American production, seemed to miss the full implication. What crucial lesson about modern industrial warfare were they failing to learn, setting them up for an even greater shock later on? Understanding these details really changes how you see the war effort, doesn't it? If you're finding this interesting, consider subscribing so you don't miss our next story. Beyond the purely material effects, the reliability and sheer quantity of American ordnance, underpinned by dependable fuses, also had a significant psychological impact on both sides. For the German soldier on the receiving end, the experience of enduring near-constant, effective artillery barrages or heavy aerial bombardment was deeply unnerving. While they might have initially held technical respect for their own weaponry, the overwhelming nature of American firepower often induced a sense of futility and dread. Memoirs and interviews from German veterans frequently mention the psychological toll of American artillery, often described as relentless and inescapable. This wasn't just about the number of guns. It was the fact that the shells arrived and exploded with terrifying regularity. This constant threat could erode morale, disrupt sleep, and make even simple movements costly and dangerous. While perhaps not consciously attributing it specifically to fuse quality, the overall effect was a grudging, fearful respect for the material power the Americans could bring to bear. Did this filter up to the high command? Perhaps not effectively enough. Underestimation rooted in ideology and early successes can be hard to shake. Reports from the front might be dismissed, or the scale of the problem not fully grasped by leaders far removed from the daily reality of exploding shells. Conversely, for the American GI, confidence in their equipment was a vital component of morale. Knowing that their grenades would explode, their mortar rounds would function, and their artillery support would be reliable gave them a crucial edge. In the chaos of combat, trusting your tools is essential. While soldiers always find things to complain about, the general dependability of American munitions, including the Fuzes, meant one less thing to worry about. This confidence allowed them to fight more aggressively, trusting that their supporting fires would be effective. It fostered a sense belief, perhaps, that even if the enemy had some technologically fancier gear, American industrial might and reliable equipment would ultimately prevail. This psychological dimension, the confidence instilled on one side and the dread induced on the other, was directly linked to the performance of those small, critical components, the Fuzes. The German leadership's failure to appreciate this wasn't just a technical miscalculation. It was a psychological one too. They failed to understand how the perception of overwhelming, reliable firepower could impact the will to fight. So the stage was truly set. On one side, an industrial powerhouse churning out millions of dependable, if not always revolutionary, munitions. On the other, a regime whose initial technological edge was being eroded by attrition, production constraints, and a persistent, dangerous underestimation of their opponent's capabilities. Nazi leadership, perhaps blinded by their early blitzkrieg victories and an unwavering belief in their inherent superiority, failed to recognize the profound threat posed not just by potential American wonder weapons, but by the relentless application of American industrial power to conventional, reliable technology like standard fuses. This fundamental misunderstanding created the perfect storm, an environment where the next American technological leap would land with even more devastating and unexpected force. And that next leap, of course, was the proximity fuse, the VT fuse, Project Tizard's gift that Allied scientists and engineers turned into a war-winning weapon. We won't delve deep into the proximity fuse story today. That's a massive topic in itself, involving incredible scientific breakthroughs, secrecy, and a dramatic impact on both anti-aircraft and artillery effectiveness, particularly against V-1 flying bombs and later in the Battle of the Bulge. But it's crucial to understand how the preceding period, the period we've focused on today, shaped its arrival. Because the Germans underestimated basic American fuse tech and mass production capabilities, they were caught completely off guard by the sophistication and effectiveness of the proximity fuse when it was finally deployed in large numbers. It seemed to come out of nowhere, a leap in technology they hadn't anticipated from an enemy they had initially dismissed as industrially strong but technologically lagging. The shock was amplified precisely because they had failed to respect the foundation upon which it was built, the vast American capacity to engineer, produce, and deploy reliable ordnance components at scale. The story isn't just about one miracle weapon, it's about a system and a mindset. The Nazi belittlement of early, standard American fuse technology wasn't merely an error in technical judgment. It was a symptom of a larger strategic blindness, a failure to understand that in modern, total war, relentless industrial production, logistical strength, and the ability to make good enough technology work reliably in overwhelming numbers could be just as decisive, if not more so, than isolated examples of cutting-edge, complex design. This had real, tangible consequences on battlefields across the globe, exacting a toll on German forces long before the first proximity fuse ever detected its target. It's a stark reminder that arrogance, especially when facing an underestimated opponent, is one of the most dangerous vulnerabilities in warfare. So, the next time talk turns to World War II technology, remember it wasn't just about the atomic bomb or the jets or even the famed proximity fuse alone. Remember the millions upon millions of simpler, conventional fuses, the unsung workhorses inside the shells and bombs. Remember the American factories that churned them out, and remember the enemy leadership that looked down on them, failing to grasp the power of reliable mass production until it was far too late. It's a powerful lesson in humility, ingenuity, and the often underestimated strength that comes from simply making things work, consistently and at scale. What other overlooked wartime tech deserves a closer look? Let us know in the comments below. Your ideas often inspire our next deep dive. We've covered a lot today, focusing specifically on that period before the proximity fuse changed everything. For the incredible story of the proximity fuse itself, and how it dramatically impacted battles like the Bulge and the defense against V-1s, check out the video linked right here on your screen or in the description below. Thanks for joining us on this look back at a crucial, often forgotten aspect of wartime technology. We appreciate you spending your time with us.